All right, we are on lesson 1-4, distance and midpoint of complex numbers. Today's date is Tuesday, September 3rd, 9/3, 2019. Make sure you have your name and date on your paper. Is there a quiet raised hand who wants to read our objective for the day? Easy XP here, James. Laptop shut, please. Easy XP. Eva, go for it. There it is. Give yourself 50 XP. All right, so distance on a graph. So I always start with the graphical representation. I like to see a picture and then do the actual math behind it. So to find the distance of a diagonal on a graph, we need to draw what? So think of example 1. I want to find the distance between z1 and z2. It's going to be some diagonal line. Obviously, I can't just count squares because I don't know exactly where a square is, since it's hard to find the exact distance of one square on a diagonal. So we're going to draw what? And this is a review from Algebra 1. How do we find this distance on a graph? Rise and run, yeah, exactly. Rise and run, but what shape do you draw? What geometrical shape? Is there a quiet raised hand out there, James? You are indeed correct. You have it correct. Give him 50 XP. It is a triangle. What type of triangle? Is there another quiet raised hand who wants to add on to that? Fiona? It is a right triangle. Both get XP. Right triangle. So if I have this diagonal down here, let me erase this. It's probably going to mess it up. It never likes me erasing things. If I do have a line down here, you can just sketch it. If I have this diagonal, I need to make a right triangle by making these two lines right here and here. Now it's a right triangle, and that will give you the rise over run. All right, and then I need to use what theorem in order to find this hypotenuse? Does anyone know the name of that theorem with a quiet raised hand? Only one person remembers. It's like the most famous triangle theorem ever. Andrea?
Wait.
Try it. Pythagorean, yeah. Pythagorean, give her the 50 XP. Pythagorean. Pythagorean. Yep. If you were part of that cult under Pythagoras, then you would attribute this to Pythagoras. Even though Pythagoras definitely was not the first person to discover it, there were many, many people before him that discovered it. We name it after Pythagoras. Don't know why. Well, I do know why, but it's kind of funny, I guess. So that's the idea. Make a right triangle, use Pythagorean theorem. Let's do it. Example 1. We made our right triangle. What is the length of this bottom leg? Give you guys 10 seconds, and then we're going to shout it out after 10 seconds. Don't shout it out now. What is the length of this bottom longest leg? You're counting squares. Get ready to shout it out in 3, 2, 1. 6. Label it 6. Give everyone 10 XP because that is a procedural XP. All right. And then the far right has a distance of shout it out. 3, 2, 1. 3. Everyone 10 XP. All right. So if it's 6 by 3, now we have to use the Pythagorean theorem. Is there a quiet raised hand that can tell me how to set that up, Stego?
With the formula?
The formula, yes. B squared is equal to C squared. Perfect. Do you know how to fill in that formula too, Stego? There it is. 6 squared plus 3. Oh, I don't know why there's a plus. 3 squared is equal to, what are we going to say that is? Stego, you can leave it C squared, X squared. What variable do you want squared? Y? C? Okay, C squared. Perfect. Everyone write it down. We are using the Pythagorean theorem. I guess I should have written it down up here again. That's A squared plus B squared is equal to C squared. All right. I now need to square both of these. Quiet raised hand. Who can square them and add them at the same time? Well, you can do them in 2 separate steps. Fiona? Plus 9 is equal to C squared. And when you add those together, Fiona, you get 45 is equal to C squared. Thank you, Fiona. That is 50 XP. And I need to find C. I don't care what C squared is. I want to know what C is. I want to know what this length here, we'll call that C, I guess. What is this length C? How do I get C by itself? How do I undo squaring it? Evan? There it is. We're going to square root both sides. Give yourself 50 XP. When we square root both sides, the square root and square cancel each other out, and I get C is equal to the square root of 45. But on Khan Academy, I'm not sure if Khan Academy will let you enter that because it's not simplified. While square root of 45 is the correct answer, let's practice simplifying, just in case we do need to do that in Khan Academy. I didn't actually check. So square root of 45, make our factor tree. Who can do our factor tree for 45? 95. Keep going, Stego. 9 and 9, or 9 makes 3 and 3. All right. We're looking for pairs of numbers. There's our pair. The pair go on the outside, the non-pair goes on the inside, so this is equal to 3 square root of 5. And if you don't like it that way, you can think of it as the square root of 9 times the square root of 5, and the square root of 9 turns into just 3. There are many methods for simplifying or reducing radicals, and you can choose whatever you want. Give me a fist of 5 on how well you think you can reduce radicals. Are you like master 5 out of 5 at reducing radicals? It looks like we are all masters, almost all masters. It's either 4s or 5, Teflon. You got 5? Yeah, we're all 4s or 5s. Okay, so I'm not going to review that too much. The answer is 3 square root of 5. We are going to box it. That is the distance of between z1 and z2. Of course, these are complex numbers. I was really adding 2 plus I, or I was finding the distance between 2 plus I and 8 plus 4i. So now we need to find the distance when I don't give you a graph. We need to somehow come up with a formula. How are we going to do that? So let's play with example 2 and then come back here to the formula and see if we can somehow create our own formula in Precalculus. How are we going to do that? What were we really doing? The first step was finding 6. 6 was the distance between what and what? You can shout them out. What was 6? Distance between z1 and z2 on what axis? If you said x-axis, you would be incorrect. Say it louder and correctly.
Real number?
The real axis. We're finding the difference between the real z1 and the real of z2. All right, so we are going to say, I don't know why did I put a line here? I'm thinking I messed that up with the midpoint. But this should be the real of, we'll say z2 minus the real of z1. Okay, that was the distance 6 that we just found up here. What do we do with 6 once we plugged it into the formula? What do we do with this 6 right here in the formula? We squared it, yeah. We can just shout out for now. We're going to go fast through this formula. So this whole thing, we're going to square it. I'm going to put square brackets, squared. And then we're going to add that to something else. Anyone want to take a guess at what we're going to write over here? Not the real, but take another guess, Andrea. Yeah, the imaginary. So we're going to do imaginary of the z2 minus the imaginary of z1. And then I'm going to put square brackets because I'm about to do something else to that. What this is saying right here, imaginary of z2 minus imaginary of z1, it's saying take the imaginary coordinate of z2, subtract from the imaginary coordinate of z1, and that will get you 3. This thing inside the square brackets that I just wrote here is 3. It's a complex way of saying 3. Okay, and then what did we do with that 3? Shout it out. We squared it. And at the very, very end, what do we do with all of this? We did 6 squared, 3 squared, and then what do we do once we added those 2 and got 45? We did something to that 45. There it is. We square rooted it. So square root this whole thing, and now you have a formula, kind of a messy formula, but a formula nonetheless that will find you the distance between 2 complex numbers. Of course, graphically, it looks a lot easier than this complex formula. So if you can somehow picture this and make the right triangle, that's one way to do it. If you can't do that, then we have a fancy-dancy formula that you guys made yourselves to find the distance. All right, let's see if we can apply one of those 2 concepts to example 2. I need to find the distance between these 2 complex numbers, z1 and z2. Let's go back to quiet raised hands for the rest of the class unless I say otherwise. What am I going to do? Quiet raised hand. Any first inklings? Any ideas here? Fiona, talk to us. Okay, so you're just plugging into the formula essentially? Okay, so what is the, Fiona, what is the real number of z2 down here? All right, so I'm plugging in, this real of z2 is -1. So I'm plugging it in, -1. And I'm going to subtract what, Fiona? There it is. I'm going to pause right here. Make sure everyone is following along. All Fiona is doing is plugging into our formula. The real of z2 was -1. The real of z1 was -8. There does need to be a subtraction sign in between them. That's why I have -1 minus -8, or -1 minus -8. Questions? This is the time. All right, so Fiona, give her 50 XP. What are we going to do with this quantity, whatever it is? Quiet raised hand, quiet raised hand. Same people over and over. I want some new people if possible. What are we going to do with this quantity? Just judging by the formula. All right, Andrea. We're going to square it. Yeah, we need to square whatever number we have here. All right, then I'm going to add this to something else. Tell me what two numbers go here and here. What two numbers go inside these parentheses? Quiet raised hands, quiet raised hands. James, yes. 9. You don't have to do the I because the imaginary part, so it's just the coefficient, I guess. 9 and... Perfect. 9 minus 12. And then what am I going to do with that quantity, James? Perfect. Thank you, James. 50 XP. We are going to square that quantity. Okay, well, we're almost done. We also need to add one final thing to this in order for it to be the correct distance. What is that giant thing that goes over both of those, Stego? Square root. Yeah, 50 XP to Stego. Square root that whole thing. All right, let's simplify this. Who can simplify this whole thing squared? The left-hand side. What is that? Quiet raised hand. 1 minus -8 and then square it. You get what? I see one hand. I see two hands. Eva?
You want me to do the whole thing?
Just this left-hand side, yeah. What'd you get?
7 squared.
7 squared, and 7 squared is?
40.
Perfect, 49. Are there any questions as to where 7 squared came from? No questions, no questions. Yep, if you do 1 minus -8, negatives kiss, they become positive. 8 minus 1 is 7, 7 squared is 49. Moving on here to plus this one. All right, 9 minus 12, figure out what that is in your head, then square it, quiet raised hand. What is that answer? Only 2 people can do that mental math in their head. Again, 9 minus 12, think about what that is. Now square it. What answer did you get? Andrea? 9, there it is. And I still have the square root over this whole thing. Perfect. Now I need to add these two. Mr. Sindel can do that for you. That's going to be 58. The square root of 58. All right. Now we have to determine whether or not square root of 58 can be reduced. So let's make our factor tree. Quiet raised hand, 58. What times what is 58? I'll give you one of them. 2. Haha, that's an easy one. What's the other one? 2 and... Shout it out. 2 and 29. 29, can that be factored any further? Nope, it's a, what is the term? It's a prime number. So square root of 58 is our final answer. Box it. All right, fist of 5. How well can you do distance? Distance on a graph, distance from just numbers without a graph. Fist of 5. How well can you do them? I'm seeing 5, 5, 5, 5, 5, 5, 5. Everyone's a 5, a master. We'll see. All right. Now let's switch to midpoint on the back. Again, the objective is distance and midpoint. So we've done half of the objective. Here's the other half. To find the midpoint, also known as an average of a diagonal on a graph, find the average of the what parts and then find the average of the other parts. So take a guess as to both of these names. Eva, go for it.
Real.
Real and,
Imaginary.
there it is, real and imaginary. Find them separately. Find the real, find the average, done. Find the imaginary average, done. All right, so let's look at example 3, a graph. We have Z1 and Z2. Let's look at the real axis, going left and right. Well, I have -5 and I have 2. I need to find the average of -5 and 2. Can anyone do that in their heads? Good guess, but no. Again, to find average, I'll give you the formula here. I'm going to do -5, and I'm going to add it to whatever the other one is, -5 plus 2, and then divide by however many numbers there were. There were 2 numbers, so divide by 2. -5 plus 2, shouted out, is -3. Everyone gets 10 XP. Divide by 2, and then shout it out again. -3 divided by 2. What decimal is it? All right, another 10 XP to everyone. -1.5. That is the average on the real dimension. So -1.5 is right here. I'm going to make a little tick mark. You should make a tick mark as well. So somewhere on this line right here is where the average of Z1 and Z2 is. We don't know where that is, so I'm going to just leave it as a tick mark for now. Now I need to find the average in the imaginary direction. So I'm looking at 1 and I'm looking at -3. Is there anyone that can find the average of those in their heads now, knowing that you have the formula? What's the average of -3 and 1 with a quiet raised hand? Average of -3 and 1 with a quiet raised hand. Add them both together. Divide by 2. What do you get? Quiet raised hand, quiet raised hand. I want to call on someone new. This is easy math. I can call on Chris, Gio, or Teflon. One of you 3 needs to speak. I'm not moving on until Teflon, Gio, or Chris raises their hand to answer this. What is the average of 1 and -3? Add them together. What's 1 minus 3? Now divide that by 2. What is that answer? Quiet raised hand. Gio, Chris, or Teflon. Waiting for one of you 3. We're not moving until you... Quiet raised hand, Gio? Oh, yes, Gio. Your answer is... Careful. Say it again. -1. All right, there it is. So make a tick mark on -1. Wherever these 2 tick marks intersect, that is the mid segment, or the midpoint. Midpoint is -1.5 minus I. So this point right here is -1.5 minus I. Done. We found the average of each of them. And if you couldn't follow that, I did -1. Sorry, not -1. It was a -2 plus, I can't see, -3 plus 1 divided by 2. That was -2 over 2, which is -1. I. All right, so now we need to find the formula for finding the midpoint. So what do we do first? Quiet raised hand. What do we do first when we were finding the midpoint on that graph? We dealt with the real. What do we do with the real? Eva. We found the average of the real. So how do I say that? The real of one plus the real of the other. How do I say that? Eva, go for it. Real of which of these points? Which one, Eva? Z1 plus what? Real of Z2 divide by 2. That's the first coordinate. And then the second coordinate. I guess you don't really need parentheses. And it's going to be plus. So that was the real part, and then the imaginary part. So Eva, give yourself 50 XP. Someone else do the imaginary part. This was the average of the reals. Now I need to do the average of the imaginaries in terms of a formula. Making formulas is hard, I know. But once you have the formula, then you can always refer back to it if you ever get lost. Andrea, go for it. There it is. Imaginary of Z1 plus imaginary of Z2. All of that over 2. And I add that because that's the imaginary part. I add the imaginary with the real, and that is my answer. That is the midpoint. All right, everyone has it down. Andrea got her 50 XP, right, Eva? All right, you're on it. Thank you. Our final example. Find the midpoint of these 2 complex numbers. Is there anyone that can walk me through it? For at least the first part. Chris, Gio, still haven't heard? No, Chris and Teflon. Chris, Teflon. -8 plus. Okay, -8 plus 2, all divided by 2. And what is that? Careful. -3. You found the real part. Good job, Chris. 50 XP to Chris. Teflon, you have to do this one now. You have to find the average of 4 and 7. Tell me what to write. Just writing down this formula. Imaginary of z1. It would be 11 divided by 2 because you did 4 plus 7 divided by 2, which is 11 divided by 2, which is what decimal, Teflon? Something 0.5. It is indeed 5.5. So our final answer is negative 3 plus 5.5i. Box it. All right, everyone got XP, everyone participated. Are there any questions with the sign language cue? Okay, rate yourself out of 5. How well can you do the objective, calculating the both distance and the midpoint of two complex numbers? Give yourself fists of 5. How well can you do the objective? I see a 4, a 5, a 5, a 5, a 5, a 5. Geo, Chris, where are you at? 4 and a 5. Okay, perfect. Those are really high scores. Don't do the summaries. Immediately move to Khan Academy. The summary should be for homework.